Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today I'm going to be continuing with writing some Semgrep rules. What Semgrep is it's a source code auditing tool that you can use to effectively search for a certain you define rules which effectively look for specific code which is probably bad so you can flag it. And let me pull it up. I have some rules written already here. Let me pull it up. Okay, cool. So effectively, how my current idea of doing this is I'm gonna right now I have one, two, three, four, five, six different types of checks that will happen, and I'm gonna have a defined list of functions. Although I'll probably need to get function classes since a ton of different functions are basically they're just variations of the same one from the perspective of the rules. Currently, the type of checks I want to implement, first off, is a function call. This is for functions that if they are called at all, it's a bug. A static size overflow check. This is for instances where we can definitively check from the perspective of the function call that, oh, hey, it's scanning in 0x50 bytes into an 0x10 byte space, and we can get that from the source code. We can flag that. This check right here, destination is a static size. This is going to be a check to see if a function which is scanning in while writing to a certain section of memory, if we can see that that section of memory has a static size. Ambiguous right size check. This is going to check for functions that write a specific amount of data to a buffer and that the size of the write it's variable, such as oh hey, an f gets called where the size is a variable that's important or something like that. Of course, sprintf, since that writes data to a buffer, we're gonna hopefully be able to write a check that it has a %s in it. And format string check, this is just your typical oh hey, we have a printf with only one argument. It's a format. Chances are it's a format string. And also, hopefully, that we can also write a check to see that it isn't like a static string. Now, with these functions, right now I'm just kind of going for the basic, I just want a base set of checks. What I'll probably be able to do is, for a lot of these functions, f get star copy, there's a lot of different variations of them. However, from this perspective of how we to write these checks, they are basically the same. So one thing I'll probably need to do later on is implement oh hey, this is the fgets class, which has checks for all of these different functions. But yeah, um, let me see again what rules I have written. Fgets. Okay, this is the check I have written for a static size. Wait. Effectively, I'm checking, oh hey, the source to destination, which is defined here. In the code base, does there exist a declaration where it's int char whatever followed by brackets with some size in there? Reason for that being is if it is a buffer that is established, usually some sort of array, it's going to have something like this in a declaration in the source code. Let's look at the other static size check. Okay, here we first check, is it a static size that we can get? And we check, okay, the size is the size greater than the size of the data type. If so, return it here. Now, one thing this doesn't take into account is right now this kind of assumes that the size of the destination is only a single byte. We would probably have to implement some other logic in case if it's not a single byte value, if it's a 4-byte value, that's the parameter here. And let's take a look at the last one. Variable, right? Okay, this rule has not been implemented yet, so I will need to implement it. Also, I'm just going to show you briefly. I wrote the rule for just checking if a function is called with gets. Just search for, hey, is there a gets call? If so, report it. Cool. Okay, I'm back. Now to write the rule for the variable, right? First, I'm just going to copy paste this rule here so I don't have to reestablish all of this. How I'm thinking about going after this is I could potentially do a check to see if the size is a non-integer value, because if it's a well, maybe that will work. Let's see, I'm gonna Google Semgrep type check. Where's this Semgrep? Okay, I'm gonna pull up Semgrep docs here. Real syntax pattern examples. Okay, I'm just on a separate window looking through the, where is it? The docs to see what the type check is. Nested statements, strings, nested statements, wildcard, statement, recurring expressions. Okay, I think it looks like here the pattern we can go with is pattern. First, patterns. Continue looking through it for a second. Okay. Actually, I think what we do is we just have a single pattern here and have it as an int. So we just effectively the pattern is f gets with 3 arguments, where the second argument is an integer. Now, what it could do very well is see that this variable is an integer data type and just flag it regardless if there's a constant there or if there's just a variable size there. This could not work. What I'm trying to get at. So let's go ahead and run it. Where is it? Semgrep. Cool. What is the syntax for this again? Did I write it down? I think it's semgrep tech config equals rules f gets variable right, and then example source. Okay, so the rule ran and it did flag, oh hey, these have integer values. Now I'm going to write a quick C source code file that has a variable there that is ambiguous and see if it flags it. Right now, this rule, it effectively checks for the opposite of what we want the rule to do. Reason for that being is if this matches, we can effectively just have a like if not. So if this doesn't match, then flag it. That's the whole idea behind this. So, actually, if gets, no, I'm just gonna, I really need to get the source code for this, not a instance right now, just like QQ, I don't know. Okay, writing, this effectively just calls this function, which has an integer x, if get char high. Okay, let's make sure that it compiles, that way you won't have issues with it parsing the source code. Forgot a semicolon. Oh, and it needs to be declared before main. Okay, compiles, cool. That source code is valid. Let's see what happens when we run Semgrep on it. So we see that this is getting flagged. So indeed, what we're seeing here is that it's just checking the type of the parameter here. Since it is a variable that is an integer, it is flagging it as such. Um, it's what we need to do is see if we can get some constant propagation going. However, currently with Semgrep, it has like 20 or 30 different languages that it's, or maybe like 10, I'm not sure. As a series of languages that it supports. Currently, C is still having features like constant propagation being added. However, I'm pretty sure there's other ways we could do this. What I'm wondering is, so with the static size, we're able to actually do a comparison to see what this value here is. What I'm thinking we might be able to do is just do a numerical comparison against this value right here to see if it's like greater than 0 or something like that, or like less than 0. So I'm gonna move that over there to use that as a reference. Static variable, right? Cool. Meta variable comparison. Okay, let's just do a comparison that size is greater than 0. And we need to define the meta variable. Cool, let's try running it. Okay, it was not work. Is it an issue with this, perhaps? Okay, so this way pattern. What line? 22. Wait. Line 10. Mapping values are not found here. What is it saying? Maybe looking at here, this meta variable comparison is just between two actual variables, whereas this isn't. So perhaps meta variable comparisons have to be between two variables. Maybe there's some other check that we can see if it's like, okay, greater than another constant value. Sorry for brushing the mic right there. Okay. I'm just looking through the docs right now to see how this is done. I'm going to pause it while I look through the docs. Okay, I got it working. It was just some indentation error or something like that. I literally just like copy and pasted this code over and just um deleted the lines. So effectively here, I'm just checking if the size of f gets if it's greater than 0. And we see here it's flagging all of the four different the four different function calls where it is a static value set in there, except for the one that we defined. Where is the source code file? Nope. Nope. Here we go. Gonna move this over so it's not in the way. except for this one. So what we need to do next is basically have it where it's like, if it's greater, wonder if it's less than. Okay, we need to have like an if not. I'm gonna look through the docs again to see how that works. I think I might be able to do this. That's just some syntax I guessed I might have. Okay, no, that's not valid. Nested statements. Okay, we're gonna pause it again while I look through the docs. Okay, I'm back. So what I ended up doing with the rule was I first established, oh hey, this is a variable, and then I just did a meta variable regex where effectively I just ran a regex on that variable itself, and that regex just checks if, oh hey, are there characters in here that would make it an actual variable, not just a numeric constant? Since a variable just can't have numerical values in there, just gonna say this outright. I'm not a regex expert, though how I got this regex was via just copying and pasting off of Stack Overflow. But another thing about this, I'm not sure quite why, but there is an fgets call in here with OX. One thing I was concerned about is with certain things like hexadecimal characters, they have an X in them. So, or they have non-numerical characters in there, like hex has, yeah, that X in it, like I was just saying. And I was concerned that this regex would flag that as something else, but it appears that it isn't doing that. What it might be doing is it might be just converting into its actual numerical value, base 10 value. So it wouldn't be like OX400 anymore, it would be 1024, and it might be running the regex on that, but I don't know. It works. I'm moving on. Love to do that. So we have at least one function function check for this one, this one, this one, this one. So you just have the sprintfs left. This is gonna be fun. Now I'm gonna quickly just write a sprintf source code file, which has a like a %s in it, and then work from there. Sprintf. Sprintf overflow.c. Okay, let's have char input 20 char dest 20. This is kind of nonsensical code. It won't really do anything, but this should model what I wanted to see. Just %s input. And let's make sure it compiles. It does compile. So effectively, sprintf will just write the data from input to destination. Of course, looking at here, nothing would really happen too much since input never has any values written to it. But this should be good for purposes of wanting to flag this type of sprintf call. Now let's write a sprintf rule. Also, I need to. I need to change the actual. There's a lot of effectively just code base is a mess. Need to clean it up. Sprintf s. So let's With sprintf, it takes a variable amount of arguments. The two arguments that it definitely takes, the first argument is the destination, second is the format string itself. As we can see here, sprintf, oh hey, takes the destination, the format string, and then an arbitrary amount. So let's model that with our pattern. Destination, format string, then just an arbitrary amount. Now, what we can do for this is we could potentially just do another regex to see if there is a %s in it. For this, I will just quickly Google regex, see if string contains any one of substrings. I'm going to pause it while I Google for regex. Okay, so I'm back, yeah. I found a regex. This regex right here will effectively just check if a string contains this substring. And I have an OR expression here, so it's either this expression matches or this expression. Only real difference between these two is it just checks if the S is uppercase or lowercase. And we see over here we have a source code file with a bunch of text and a undercase %s in the middle of it. When you run it flags it, changes from undercase to uppercase. We run it, and it finds it again. So this rule type right here is sprintf's %s check. We've done that. Only one really left to do is just this format string check with printf. So let's get started on that. Rules, printf, format string. I think this one was probably going to be a bit simpler than the other ones we've done. Yeah, I need to fix that for all the rules. Printf, if. So in order for a format string to be a format string, it needs to contain just one argument, so we can do that. And we can do a check to see with regex to see if it doesn't contain quotation marks. So I'm going to Google that real quick. Regex check if string doesn't contain substring. I'm going to pause it while I look at this up. Okay, I'm back. I found a regex that works. It's this one right here. This regex effectively just checks if it checks to ensure that the string does not contain any of these characters, which I have put effectively the two like double quotes and single quotes since those are used to define a string. Here we have here printf vulnerability just printing a single char buff or a potential one. We run it, see that it flags it. Add quotes around it to turn into a string, such as the static printf. Doesn't flag that because of the regex checks to see if it has any of those characters. And we go ahead and add single quotes, and we see it no longer flags that. So the printf check works. So we have a check for each of these check types. I'm going to go ahead and just implement the rest of them through these other functions, but I'm going to wrap it up here for this video. Thank you guys for watching.